Okay, so hello everybody. One more time, thank you for coming to the second, which is a huge success already, second Budapest LabVIEW User Group meeting. I see some of you for the second time, some of you for the first time. Who was here the last time? Okay, so almost half of the people that we have today are new, which is fantastic, huge success. I'm very happy and I'm very proud that you guys are helping to build this community. We are building this community together. This is very good news. I am honored and proud of that. So, Budapest LabVIEW User Group number 2. During the first meeting, we started a wonderful tradition, and it's finally time to meet again. We're going to be meeting every 3 months. I hope you will all feel that is not frequent enough. Welcome to the second Budapest LabVIEW User Group. Because the year 2020 is the year when LabVIEW finally gets interface support in object-oriented programming, that's going to be the theme of our user group this time, object-oriented programming. So I've tried to reach out to some of you. I've tried to gather the topics for the presentations, and I'm going to be giving the first presentation about solid programming principles when it comes to object-oriented programming. Second presentation will be by Denis, who's going to talk about how is this called? Separation of concerns. I always forget the name. Which is another principle that helps us build nice and scalable object-oriented applications. Then a presentation about unit testing, which is extremely important when we want to build big applications and prove that they are doing what, in fact, we want them to do. And then one last presentation at the end, if everybody has enough strength to listen to me for the second time, is going to be what can we learn in our object-oriented applications that we write in LabVIEW and graphical programming from functional languages. Right? This is a presentation that I was giving at the CLA Summit, so I wanted to give you a little bit of a flavor of what's going on CLA Summits if you didn't have a chance to attend. Okay, I need to start with this. I'm going to probably be starting with this, or I hope the next leader of the Budapest LabVIEW User Group will always start with these type of slides. So let's build the community together. It's very easy, just 5 steps. Let's follow the manual, and we will have a wonderful LabVIEW User Group community. So join the forum. You have the forum links available on the agenda. Just need to scan the QR. It's going to take you to the forum. You can join there. Follow the hashtag #BudLook, Budapest LabVIEW User Group, on LinkedIn and Twitter. When there is new information and you don't want to go to the forum or you want to get some updates, this is going to this is going to be the place where you get the updates. Share your ideas about the next topics for the user group meetings and topics of presentations that you would either like to see or would like to present yourself. And we are doing this on Poly, and you also have the link to that on one of the pages there. So you can go, even right now, we are gathering the ideas for the presentations for the third user group meeting, which is going to happen in April. Volunteer to become the leader in the community. So this requires some time from you. This requires an investment, but you can help to navigate and steer the direction where this community will be going. Just send me a message and we can start talking about it. Yeah, and volunteer to present. So whenever you have an idea for a topic that you would like to see, it's an option that you can present that topic. So meetings are happening every 3 months. I think that's going to be the perfect amount of time between them to prepare for the next one. And it's on the third Wednesday of each month. That usually turns out to be around the 15th this year, at least. In 2021, it's going to be on the 13th. But that's a long time in the future. It's Wednesday because it's just easier for everybody to attend. You're not going, if you're not working in Budapest, not living in Budapest, but just traveling home for the weekend, then Wednesday is a perfect time where everybody is still here and available. It's at 5 p.m. because I don't want you to take a day off just to be able to visit here. But these are all, you know, the initial values. We can update them. If you have other ideas, better ideas, this community is for you. This LabVIEW user group is not led by me, or maybe now, but in the future, I want it to be you guys that lead this. So if you have other ideas, just shout out, hey, I have an idea. So right now, before we go to the presentations, I already want you to start thinking about the next meeting. We have some ideas what the topics for the next meeting might be. For example, integration of LabVIEW and other languages / environments. That might be a good topic to talk about. Or maybe a little bit more broadly, IoT in factories. How does it look like in real life? What do you think? Yes, perfect.
I have a suggestion for the agenda.
Yes.
So I already did some guides that I would suggest to have not only presentations, but a roundtable discussion as well. So 2 presentations and a roundtable discussion where this is not like the way that somebody stands there and shares a topic, that we pick a topic like how you, I don't know, document your problem. What are the measures that you're using, what are the pitfalls, experiences? We pick a topic and discuss it, and everybody can share their own experiences and share what they do.
Fantastic idea. Who else thinks that's a good idea? To change one presentation into a roundtable discussion. Okay, because my last presentation today was a filler presentation. We didn't find anybody who would want to present in that slot. Would you guys want to change the last presentation into a roundtable discussion today? Yeah?
We can find it.
I have 2 topics. One topic is the how to document your code, like object-oriented or not object-oriented, but yeah, it's mainly important if we have an actor framework, architecture, developer framework.
Okay.
And the other topic is what kind of user interface do you use if you want to change it programmatically? So GKI, flat UI, GMC, what kind of experiences are the topics?
So it looks like we already have topics to talk about. Okay, so let's do the roundtable discussion as instead of the last presentation. Everybody in favor of that? Yeah, cool, fantastic. But what should be the topic of the next meeting? We don't have to answer this question right now, but I would like you to think about it today, since we have the momentum. You know, everybody is excited. Let's continue this excitement and transform it into a topic for the next meeting. And please reach out to me with the presentations that you would like to give or see. So you can always go to the Poly link and vote there as well. And there's one more thing. I don't want to focus on this too much, but I have, my manager wouldn't, forgive me if I didn't mention this. So there are these 2 job descriptions. If you want to have a look at those, feel free. I'm going to put them here, and that's it for the job description. Okay, cool. So we're ready. Let's go to the first presentation. And here, first of all, I wanted to ask you all, what is your experience with object-oriented programming? Who did object-oriented programming in LabVIEW before? Yes?
Yes. You could take a good picture.
What?
Until everyone's reading.
group picture. Well, I'm.
So maybe we can do it after the first, like during the first break.
Yes, during the first break, after the first presentation, group picture. Yeah. Okay. Okay. So who tried object-oriented programming in LabVIEW? Let's include in other languages in LabVIEW. Okay, so majority. Did you ever hear about these solid design principles in connection to object-oriented programming? Who heard about solid design principles? Okay, less. That's good. I want to mention these because these are very tightly connected to the way the industry, software engineering, does object orientation. So these design principles help you design bigger applications that still behave well, even though they are very complex and big. So if you don't follow these principles, usually it turns out that you're going to be stumbling along, trying to find your way. Oh, it doesn't work like that. Maybe it's going to work like that. And you're gonna approach more and more correct, more and more flexible, easy to use, proper solution to a problem. And then, at least this is what happened to me, you're going to realize that this, in fact, was one of the programming principles. So if I knew about it before, I wouldn't need to do that big experimentation, learning for a year how to do it right. Instead, I would be able to just immediately apply the principle, how it looks like, and I would get the proper design. So this is this presentation I already when I was working on it. So we have many programmers in our teams, many LabVIEW programmers in our teams, and we want them to do object orientation for many reasons. But onboarding new people was challenging. It was difficult. When we wanted to teach them these principles and the design patterns connected to that, it was quite difficult because all of the existing materials were, in fact, in some text-based language. So either C# or Java or something like Python, maybe, something like that. But it was difficult to find examples, proper examples in LabVIEW. So I've tried for this presentation to prepare these types of examples. So we're gonna look more at demonstration, how these things look like in code, rather than just talking about them, very long discussions. And so I'm gonna show for each one of these, this is an acronym. This stands for something. Each letter stands for something. I'm gonna be showing you demos. Okay. Not necessary. Let's have a look at this. Goals of software design. There was a fantastic presentation given by the inventor, let's say, of these programming principles. His nickname on the internet is Uncle Bob. His name is Martin. He was one of the people on the meeting where agile software development methodology was invented. So it's very beneficial to follow him actually on Twitter and read what he has to say. So he invented these principles, or actually grouped them together. They were existing in the wild. He just grouped them together. And one of the important things that he said, that software is supposed to be soft, which seems kind of obvious if you think about it. It's in the name, right? But very frequently, when we are working on big applications, we come up with a huge design, and that huge design, if you think about it, is hardware at some point, because we cannot touch any part of that design without the other part of the design breaking. So it's basically all or nothing. You make a small modification, everything falls apart. Right? Have you been in these types of situations? Yeah. So software is supposed to be soft. So first of all, we need software to handle the current requirements. But that's point number 2. That's less important. What is more important is what does this current. What does it mean right now? What are the requirements right now? Well, I don't know what the requirements are right now. First of all, I never get the requirements, right? I have to pull them. I have to extract them somehow. It's never given to me. And immediately when I get something, the situation has already changed. So it's more important that the software is actually solved, and it's malleable, and it adapts to change. And good design, if there is anything that can be used as a definition of what a good design is, it's a design that is easy to change. That is like, when we don't know anything else, this is definitely something that is important for a good design. Maybe high throughput in certain situations, maybe matching some requirements perfectly. That's good design, yeah. But something that is always there is it's easy to change. There was a question: why OOP? Why object orientation? Why do this approach this problem of complexity in that specific way? And an answer to this question is, how many times have you written the same code in separate projects? How many different standards were there for implementing the same functionality or the same set of features in all of these different applications and projects? How much of that was reusable? Maybe if we standardized as a community, maybe in your company only, but it would be even better if it was a standard as a community. If we standardize on one methodology, one approach towards solving this complexity, and we wrote our applications in similar ways, maybe that would give us some benefits. We could exchange code with other people in the community, or read somebody else's code more easily, or maybe plug and play something. So what are the functionalities that I've seen for my projects that I'm writing over and over again? State machine flow for every application is the same. Yet I write it over and over and over again. Threading functionality, spawning something asynchronously over and over again. And the whole list: hardware abstraction layer, measurement abstraction layer, templates, some utilities, dynamic user interfaces, frameworks, all of these things over and over again. So how do we implement these? Let's make a choice. Fortunately, the industry made a choice for us a long time ago. We just need to adhere to it. So what do I mean when I say object-oriented design? Following the s'mores principle, we want to achieve these things, right? I'm not going to repeat that. But what I mean more even than that is we standardize on something, we follow the design principles, and we follow the design patterns. What I don't mean is people often think that object orientation equals complexity. That is not true. I will try to show you in my examples that that is not the case. And especially for LabVIEW, that is not the case. It might be the case where objects, in other languages, where objects are passed by reference. That quickly turns into a lot of additional complexity. But in LabVIEW, in language which is data flow based, that's not necessarily true. And I also don't mean that everybody needs to be an actor framework expert. That is not, the object orientation does not equal this. For Dennis it does, but for everybody else it doesn't need to. Yes, okay. So let's skip these things. Okay, this is also important. This is from Stack Overflow, yes, Stack Exchange. Why include support for object orientation directly in the language when procedural languages can be used to design and write modular, reusable, and extensible code? Fantastic question. To prevent from having 22 or more different ways of solving the same problem. So that's exactly the same case for us. For single responsibility, open closed, list of substitution, interface segregation, and dependency inversion. Clear? All of these can be summarized in a single sentence. And if you remember that single sentence, let's say, or the summary, you don't need to remember the acronyms necessarily, but if you remember the sentence and you remember the example that I will show you quickly, we don't have too much time, then you will understand how to apply it. Classes should do a single logical thing. If your class does many, many, many things, then it's bloated. It's unnecessary to do so many things in one place. You want to separate those responsibilities. Open for extension, closed for modification. If I've finished writing my code and I put it into source code control and it was approved by my manager and it was tested and it's stable, I don't want to touch that code. So what do I do if I want to add new functionalities? The keyword is add. I add new stuff. I don't modify the existing stuff. You should be able to substitute a child for a parent. This is connected to inheritance. Just let me ask the question, who here is familiar with the concept of inheritance in object-oriented programming? Okay, some of you, but not everybody.
Sorry, what is Liskov?
Liskov is the name of the person who came up with this principle. Yeah. When you write an application that works with a generic data type, and your application is written to work with that generic data type, and then you want to add some more details, so you create a derived type from that generic data type, and you put that derived type through your application, you better make sure that the application works the same way as for the generic type, at least. It can do more, but the derived type should never break the application written for the generic type. Interface segregation is the same as single responsibility principle, but for interface design. And dependency inversion is put interfaces between classes. As simple as that. Put interfaces between classes. Okay, there are two things here on this list that are questionable or problematic a little bit. So interface segregation and dependency inversion talk about interfaces. And this presentation was created at the time when interfaces were not a thing in LabVIEW. In LabVIEW 2020, we will get support for normal, full-scale, full-featured interfaces. So we're going to be able to implement properly these two principles. For now, we have to use a cheat until we get LabVIEW 2020. So from LabVIEW 2020 onwards, we're going to be able to do these things properly. Okay, so let's go to the demonstrations slowly. So one more thing, for every demonstration, I'm gonna try to show these slides one more time. Here I just have examples. So what is the example of a single responsibility principle? This is a little bit contrived, but it follows the principle really nicely. Text formatting class, a class that is designed to process text, should not have the functionality of saving text to files or databases. Parsing text and saving text, these are two separate responsibilities. A measurement class should not define how measurement data is visualized on the screen. It's a measurement class. It talks to hardware, let's say. So it's not, it shouldn't define the visualization. If you separate these things, it becomes much easier to think about your code, but secondly, it becomes much easier to actually substitute elements one for another. Okay, so let's have a look at the single responsibility principle in action. I had it open here, actually, already. So single responsibility principle. Do I need to do it like that? Yeah. Okay. So here I have single responsibility principle project. And the project, I have two classes. One is journal, the other is persistence. And the name is not important here. The concept of what it does is important. So the journal is responsible for collecting together journal entries and adding an index to them. So first entry, second entry, and these are just string values that I'm capturing, right? And the persistence class is responsible for saving the journal to a file and loading it from a file maybe in the future. Maybe also in the future it's going to grow to have database support. But I wouldn't necessarily want to put all of that functionality inside of the journal. So if I violate the single responsibility principle, I'm going to put my saving and loading functionality here. Or for measurement class, that would be show on screen. And then we pass in the reference to the graph, let's say. That is violating that principle because we are coupling more and more things together into a single class, and it grows and grows and grows. So with single responsibility, we want this journal to be responsible for capturing these nodes. So main for this application is going to look something like that. So here I'm going to have the journal. I add the entries that I want. This is just for debugging purposes, showing something on the screen. And then I have the persistence class. I save it to a file. And I pass in the persistence class as an input to the save function. The journal is the argument. It's one of the inputs. Any questions? Yes.
Okay, I expect that maybe we'll cover this in the next presentations, but I'm not necessarily agreeing with this approach too much. So why not? So why are you passing the entire object into the saving into the save class instead of really providing a method that sends the data that needs to be saved itself?
Fantastic. That's another point. That's another extension of this idea. That's a great question.
I'm saying that maybe I'm presenting this in the next class, but here probably it would be much better to have a method that gets the data and then indeed you are decoupling the two.
Fantastic. That's absolutely true. I'm not decoupling here because I don't want to overcomplicate this example, but in the real world, you might even go one step further. Instead of making the persistence class depend directly on the journal, you would make it depend on some type of maybe universal data type, like just an XML string, let's say. So then these modules are really truly decoupled one from another. But I didn't want to overcomplicate the example. Okay. Let's go to open-closed principle. This is a bigger demonstration. I'm going to give them that. We define most of the algorithm, but there are some things that are dependent on that specific customer that we are working for. So we have a framework. We get the requirements from a customer. We plug into these requirements into our framework, which is mostly complete, but we fill in the blanks. So we are open for adding functionality, but we are not modifying any of the existing code. So we have a generic application that is written as a sequencer that defines the flow of operations without hard coding the details. For this, we need some sort of an interface. Things like plugin-based applications. This is going to be a keyword that you will also find them implementing these types of things, plugins, dynamic plugins. Yeah, and this talks about also the very moment you finish gathering the requirements, they are already outdated. So you can start gathering them again. So when do we start writing software? We should at the beginning, but we need to make our design open for extension. Yes, so think of plugins dynamically loaded when needed. This can be done with VI Server, but it should be done object-oriented. Okay, let's have a look at the demo. Where is mine? Here we go. Let's close this. That was... Just a second, let me find it. Here we go. Okay. So for open-close principle, I have a situation where I've created an application that works with products. And these products can have multiple characteristics in them. They can be, they have size, and they have color, and they have a name, let's say. And I've got the requirement from my customer that I want to be able to filter a list of products by color. Fantastic, okay. I wrote an application that does this. I think I have only the good solution here. Okay, so let's imagine I wrote the application that hard codes this functionality into my product specification, let's say. Product can be filtered, so I create a function that accepts a list of products and hard codes filtering them based on color. Okay, done, finished. I finished the class, I finished this class, I package it up, compile, deploy. And now the customer comes to me, okay, but I also need to filter not only by size, but by color also. Okay, so I need to open up that original class, modify it again, do the acceptance testing, do the unit testing, deploy. Another feature, I need to filter by name. I need to have a specification that allows me to filter by name and by size. By size and by color. By all three. And permutations start to grow if we continuously edit the original class. So we don't want to do that. We don't want to modify. We want to close for modification, but open for extension. So how do we do that? We need to use interfaces, actually. So a single interface is allowed in LabVIEW. You can have one interface, which is good. Soon we're going to get the ability to have more. But how does it look like? A proper solution that is a... Oh, no, we had the bad solution here. Yeah, OK, so product filter. Here we had a closed filter that was violating this principle. So it was... We needed to define these types of filters, more and more and more methods to perform the proper filtering that we want to do. And we needed to always open up this product filter and do the modifications. We can have another approach. So let's have a look at the main. So here we create a list of products. A green apple, which is small, a green tree, which is big, a blue house, which is big. And now here we have the closed solution. I think this is closed solution. Yes, I think that's correct. Yeah. So a closed solution would be to create a filter which operates on a list of products, gets that specific aspect of the product, that specific property, and then compares it to something. So whenever we want to add a new feature to our product and we want to add a new filtering for our product, we need to basically touch always this closed implementation of the product filter. So this is for a product filter. We need to always touch that, modify that. That's one approach. The other approach is to create an interface for the specification of the filter that we want to use. What is that filtering? This is going to be a generic filter. It can filter any property of a product. So if you add new properties in the future, you add a new filter type. You don't modify any of the existing code. You add a new class that is going to be defining the filter type for you. And maybe in the future, you're going to have even a better implementation of the filter itself. So you can also specify an interface for a filter in general. So here, I've implemented it like this. So here, I was modifying the same class over and over and over again. Here, instead of doing that, I'm adding specifications for filters. Each of these specifications inherits from a filter specification, which defines for me the interface. The interface is very simple, just a single method. This filter is satisfied or not. Let's have a look at how this BI looks like. So it accepts the filter to define what operation I want to do, and then accepts a product. What does it do on the inside? Well, it doesn't do anything because it's only an interface. So it's not intelligent in any way. It's just an interface. This is the inputs and the outputs that I want to have. But if I prepare a color specification for filtering, then is satisfied for color specification, does this. And I invoke these specifications in my better filter. My better filter has one method in it, filter. This method's interface is the filter itself, the array of products that I want to work with, the filter specification that I want to use, and I'm returning the filter list. On the inside, looks like this. Now, what this can do is it accepts an array of products, any filter specification that you wire here. The keyword is any. It can be dynamically loaded from a file even when the application is running. Any filter specification, wire it here. It dynamically dispatches. I can have a look at these specific implementations. Dynamically dispatches to what is necessary for that filter. What options does this give me? I can have, so this is my filter method for a better filter, right? And I accept the specifications for filtering. So this is going to be filtering based off of color. This is going to be filtering based off of size. And here I went crazy and I created a new filter specification that didn't exist in the original requirements. But my customer came to me and, hey, I want you to filter by size and by color. So I was like, and? Interesting. So let's put those together. Let's create an array of specifications. And I'm going to call that and. So however many filtering capabilities you want to have, you can create an array of those and check if all the conditions are met. So that's going to be an and specification. An and specification is inside just an array of specifications. And when I do filtering for an and specification, sorry, I have to go there, wait, here. For and specification, I'm just iterating through all of the specifications and making sure that all of them are met. So adding new capabilities to an architecture which is open-closed means really adding new stuff, adding new classes. But you need to prepare. So there is a price to pay. It doesn't just happen spontaneously that you're going to have an open-closed application. You need to prepare with the interfaces for these plugins. If you need more time to have a look at that, I'm going to be sharing all of these examples with you online. So you're going to have access to all of this code to go through it in your own time as well. List of substitution. I don't think I need to show the example for this because it's kind of like, it's difficult to explain right. But the point is, an application which is written for a parent should not break when a child of that parent is used instead. So let's take a look at the filtering application that I have there. If I defined my filtering application, my main, is using filtering based off of the iFilter interface, let's say. So we've created this interface, and we've written the application on this generic type. And now we pass a specific filter there. The unspoken contract here is that this filter is doing filtering. If it now starts to do some other weird stuff, that can potentially break my application. So let's imagine this filter now, instead of just being a filter, it starts to read some stuff off of my hard drive. Or it maybe sends something to a database. Or it pops up a dialog box on the screen. You would probably be mad at the designer of that filter. I told you that I want you to do the filtering. This is the interface. Just do that, please, right? So he would be violating list of substitution principle. Another thing connected to this is inheritance is dangerous and difficult to understand, especially when it grows. So another, let's say, sub-principle connected with this is try to limit the inheritance that you have in your application. The inheritance relationship should be viewed as a potential bomb every time you use it. So 100 times, 99 times out of 100, you're going to be absolutely fine, but then 100 times, it's going to explode in your face. So inheritance is, we need to be careful. So I recommend, that's my personal recommendation, limit the number of layers to 1 in your inheritance relationship. And that effectively means that you are creating interfaces and implementations of these interfaces. And this is absolutely fine. So you can do that without any problems. The moment you have more than 1 layer, you should have a good justification of why. And it is much safer to add complexity into your application by composition. So one class is composed of multiple other classes. So inside of its data, it has other classes, instead of using inheritance for those exact reasons. Single responsibility in interface design, the interface segregation principle. Not every class that is sortable needs to be searchable. Let's say if your product implements a couple of interfaces, for example, you can search by size or search by color, and you can also print that product. These are all separate functionalities. You don't need to put all of these functionalities under one kind of parent class, and your class is inheriting from the parent. Not everything come from one place. You can have separated. You can have these functionalities separated. So let me show you a demonstration of that. Okay. Close this. Interface segregation principle. Okay, so here the example that I have is I am writing a driver for this Office Island device that prints, scans, and faxes messages, right? Or documents. So I'm writing this driver right now. So in this driver, let's say this is my interface that I've created for this machine. Okay, fantastic. These were the requirements for my application. It was supposed to be a machine. Great. So I've created an interface for a machine. And this interface does three things. It faxes, it prints, and it scans. But then another department in my company told me that, okay, fantastic. It was a huge success. Your driver is great. What a wonderful architecture. Now we want to produce devices that only print. It's going to be relatively easy for you because it's only a third of the functionalities that you needed to create last time, right? So just take the original design, take the original software, and just reuse that for this design. Only printing we need this time. Okay? So what do I do with the other things? So I'm inheriting in my class that implements this interface, and maybe even a bigger application. The big application expects that something, which is an iMachine, has the capability to do all of those three things. Faxing, printing, and scanning. Or maybe, for an example that is closer to our hearts, a measurement device can generate, acquire, and visualize data. And we've put all of these three things under one class that we call measurement device. So now what do I do if I want to just have a printer? Okay, I make the printer inherit from iMachine, and it's going to shout at me that, hey, you didn't implement these required override methods if they were set to required. If they weren't set to required, then maybe it's going to be something like that on the inside. So it's going to be a no operation. When I try to invoke faxing on a printer, it's just not going to do anything, which is okay. But what if there is a one-button dialog because the designer of this interface said, not. And it's going to return errors for me if this method is called. So I've accidentally created an interface that includes too much stuff in it. I need to separate these functionalities. Again, single responsibility principle applies to interface design as well. It's so important that it's twice in the solid design principle, single responsibility principle. So I create iPrinter that includes print, iScanner that includes scan, and multifunction printer should be working together with both of these interfaces. Now there is a gotcha here. Currently in LabVIEW, when you specify inheritance, properties, inheritance, you can only specify the inheritance from one parent class. So you can inherit only from one interface. In LabVIEW 2020, you will have the ability to specify multiple, which means that you will have the option to inherit from multiple interfaces, which is absolutely the thing that we need, and it's fantastic. For now, we have to use a little bit of a different approach, which is called the twin pattern, but it's a little bit too complex to explain right now. So I'm just going to point you to the materials about the twin pattern after the presentation, and you're going to have a chance to read about it yourself. Yeah, but we want to separate the interfaces. Oh, this is This is the twin pattern. It's called here translation mechanism. Maybe I can rename it twin. Okay, fantastic. So that was interface segregation. And last one, and after that questions, dependency inversion. With these requirements that we have that always change, constantly change, if we write our application where one class directly depends on another, one class calls the method of another class directly. So this can be, for example, our UI, or even better, so this main app, and this is the device. So if I'm calling the methods directly, these two modules are tightly coupled to each other. So if the functionality of this module changes, if there is a new requirement, I need to add a new feature to the device, that means that I will have to touch the main. Because it's called differently. I need to do some additional function calls in the main. But I don't want to touch the main because that's a different module. And how do we prevent this coupling from happening? We inject between these two things another thing, which is our border protection mechanism, let's say. And this third thing here is going to be the interface. And now, the arrow of dependency from the main to the device, it was going like this, now it's going like this. So both these classes now depend on an intermediate class, which is performing basically translation between them. And this separation allows these two modules to evolve and change really independently, as long as the interface between them stays the same. Example, measurement application should not depend on the driver details. Instead, the driver details should depend on a hardware abstraction layer. And that's another keyword that you're going to read and see everywhere, abstraction layer, measurement abstraction layer, user interface abstraction layer, hardware abstraction layer, file abstraction layer, network communication abstraction layer. Whatever you need, whatever is changing, that's when you inject this abstraction layer there. And that is the dependency inversion principle. So let's have a look at the demo. Yeah. Class translation mechanism should be used. I called it also before class mutation mechanism or twin pattern. I'm going to send you the details on that. You can review them afterwards. But let's have a look at the demo. Save. Okay. Fantastic. Very complex architecture here. Main application does not depend directly on the specific DMM that I'm working with. Instead, it calls and works with the measurement interface. And then whatever device I actually use there, as long as the interface stays the same, the main application will not need to change. So let's have a look at the main. So this is the interface. The application is written working with the interface, generic type. And then the user asks me please create a driver for this DMM and plug it into your application. Sure, no problem. I just need to make sure that my new driver inherits from the measurement interface, and then it's going to play nicely with my application. And this visualizes dynamically loading it, so I can load it from a file. The specification changes somehow, so the features of that DMM change. Then in the background, I rewrite the functions of the DMM. Maybe I even add more private methods to it. It grows and grows and grows. But my main, which I'm visualizing, this is a completely separate application. This has been already compiled, tested, accepted, released, is in the repository, it's approved, untouchable, and it needs to support old and the new. So how do you add the new? You add an interface. When I'm doing the object-oriented training for customers, I tell them that this training is not object-oriented training, but it's an interface training. The word that is repeated over and over and over again is interfaces. So they are fundamental. If in doubt, when in doubt, add an interface. Yeah, and then what specific functionality is going to be called, and interface nothing, and the specific measurement class something. Okay, and that's it for my presentation and my demos. If you guys have any questions, I can answer them. Yes.
So maybe, I think also clarify for myself, maybe for the audience.
Yes.
Here, in your case, interface basically means a parent class, right? So basically, it's a parent class. It's an abstract class, if you want, with purely virtual methods, nothing else. And then basically, you have child implementations of that guy. And then this is an interface, because as long as those are child implementations, then everything is okay, right?
Yes.
Probably my approach, and actually this is how we complete each other like in this presentation, will be presenting you an interface not as only an abstraction layer, as in like as a parent class, but rather interface as an actual object. And I think, I don't know, like the approach in what the approach that you're describing, I think it's cool and it works with in a lot of situations, but I think where it might be a bit more problematic is the fact that you're actually, in a way, limited by the methods which are described by the parent class.
Mm-hmm.
So in a way that, okay, as long as I inherit and overwrite the original methods, right, and then I create my own methods, everything is okay. So everything will work. But what if I need to, so after I have defined, let's say, 3, 4, 5 children, and then I need to change the name of the method in the parent class. Right? Because, as you say, requirements are evolving and things like this. Yeah. And then I'm a bit stuck,
In object orientation, this is unfortunately true, and I agree with you 100%. If you want to change the name, don't.
Yeah, no, because it sucks very much.
Yeah, if you specify the name in an interface, if you specify the inputs and the outputs, they are set in stone forever.
Yes.
And if you want to change them, you're going to be working on version 2.0 of your application.
Basically.
No, it's 1.0.
Or you have to basically painfully go through all of the, all of the other classes and things like this. And I think you're also, you're not allowed to change the, I'm not sure, inputs and outputs, they have to be the same.
Yeah.
Right? Yeah. So in this case, also, you cannot change too much here. So you have defined, say, a very generic input, which is of type variant, and it kind of has to stay like this. You cannot add or.
Yeah.
So, just a couple words about these limitations. That's why, and again, implementing interfaces like this is very good, and it works in many cases. That's true. It's just, sometimes, honestly, I prefer really referring to the interface as really a separate object. And in this case, my interface will be really calls to that object, as in just actual messages to that.
You have that in your presentation, right?
Yes, that's going to be that.
Cool. Yeah, so we're going to see it now. Fantastic. Any other questions?
Just, come on, guys. it's really funny, you know, how everyone, including me and all the developers out there, everyone, they say that, guys, let's make things simpler. Let's save time. Let's make code more efficient, more streamlined. And if we do this, it's going to be much better. And if we do this, a little bit better, then it turns out actually about, you know.
It turns out it's all true.
Yes. True. It just gets more and more complicated. You know, like it was just so much simpler before when you had just a queue and, you know, some while loops, right? Solve all the problems. And then, okay, guys, no, let's solve this. And then it just, oh my God.
That's a good topic for the round table discussion.
Probably, you know, the complaining.
And then you need to
Complaining.
then you need to work together with less experienced colleagues.
Yes, yeah, that's also better.
Because yeah, you need to manage a team who can work with you.
So they have to make this quality jump, you know, from queues, using queues and event structures to all of a sudden abstraction layers and asynchronous.
So you mean that object-oriented architecture is a good idea when you have a team of developers working
Yes
together?
and no.
Yes and no. Okay, so another topic for the roundtable discussion. Fantastic. So guys, was this useful? Did you learn something new actually here? Is that something that is applicable in your situation?
Yes.
Yeah, maybe. Anybody? Applicable? Useful? Success. Yes. Great. Okay. So 8 minutes before we have the next slot for the presentation. So let's do the group photo, maybe.
Sure. By the way, thank you very much.